Have you ever wondered how things moved in circular shapes? These examples can be found all throughout the world. A bicycle wheel, a ball on a string, or an upside down twist on a roller coaster. This video will teach you all about centripetal force and circular motion. Centripetal force is the component of force acting on a body in a curvilinear motion that is directed towards the center of curvature or axis of rotation. Circular motion is a movement of an object along the circumference of a circle or rotation along a circular path. Both these things work together. Here is some more information on centripetal force and Newton's second law.
Let's take a closer look at the fascinating physics of this simple action. You've probably heard of Newton's second law of motion as it relates to objects moving in a straight line. Turns out, Newton's second law also tells us about the net force on an object as it moves in a circle. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means we have an acceleration. And we know from Newton's second law that if we have an acceleration, we have a net force. Now back to our spinning ball. For objects undergoing circular motion, the net force on the object is called the centripetal force. It's a weird sounding word, but it's Latin for the phrase center seeking. It's named centripetal because the centripetal force always points to the center of the circle. The ball has a tangential velocity, so if you suddenly cut the string, it would fly off in whatever the tangential direction was at the moment you made the cut. But assuming you don't cut the string and you keep swinging the ball's tangential velocity is constantly changing directions. This means the ball is accelerating, and the reason it's accelerating is due to the centripetal force. The centripetal force acting on the ball is constantly directing the ball towards the center of the circle, your hand. This, combined with the ball's velocity, keeps the ball swinging in a circle. The same centripetal force that keeps the tennis ball swinging in a circle also keeps roller coasters on the track as they go through a loop-de-loop. So the next time you're having a blast on a roller coaster, you can thank the centripetal force.
Now here are a few important facts you should remember from the last video. Newton's second law tells us about the net force of the object that moves in a circular motion. Since the velocity is changing directions, this means there is an acceleration. The ball also has a tangential velocity. This means if the string was to break, the ball would continue in that direction and velocity. It's important to remember that the ball will not continue moving in a circle. Now that we understand what centripetal force and circular motion is, let's figure out how to solve the problems. The first equation that can be used to find acceleration is v squared over r. V represents the velocity and r represents the radius of the circle. The next equation is 4 pi squared over t. T represents the time. Both of these equations can be used to find the acceleration of the centripetal. The next equation shown will help you find the centripetal force. First equation is m times ac. M representing the mass and ac representing the acceleration. You would use this equation if you didn't have the acceleration. 2 times m times v all over r. M representing the mass, v representing the velocity, and r representing the radius. The next two equations will show you how to find the velocity and the time used. To find the velocity, you would use 2 pi times r all over t. R represents the radius and t represents the time. To find t, you would use 1 over the frequency. Now all of these equations can be quite confusing, so let's try a few problems out. For this problem, the ball weighs 3 kilograms and the acceleration is 13 meters per second. Now, what equation would we use to find the centripetal force? First thing you want to do is write out your equation. M times AC equals force. Next, you want to write out your equation with the numbers in units. 3 kilograms times 13 meters per second. Finally, you multiply your numbers to get 39 newtons. Make sure you include the units. Now that was an easy problem. Let's try to find the mass without having the mass. For this problem, imagine an ice skater is moving 15 meters per second and is going in a circle with a 30-meter radius. Now, what's her mass? First step is to write out our equation, mv squared over r. Next step is to plug in all of your numbers. From the diagram, we know that the ice skater was skating with a velocity of 15 meters per second, had a radius of 30 meters, and had a force of 450 newtons. Finally, you want to get the m all by itself. First, we squared the 15 to get 225 and times 30 by 450. Finally, you're going to want to divide the 225. After dividing, you will get 60 kilograms. For the last problem in this video, we're going to learn how to use the centripetal acceleration formula. For this problem, we're going to be finding the centripetal acceleration. If a 3-kilogram block is moving in a circle with a 5-meter radius and a velocity of 8 meters per second, what's the acceleration? First step is to write out our equation, m times v squared over r. Next, fill in with your numbers. Make sure that you square the 8 when you multiply everything. After multiplying everything, you will get 12.8 meters per second. Hope you're able to learn a lot about centripetal force. Thanks from Sophie and Lucy.